right, so in 7.4, we're going to do a little, I wouldn't call it an activity, more of a discovery of two more properties that deal with multiplication. Before we do that, I'd like to remind you of what our first multiplication with exponent property stated. And it said that as long as we have the same base, when we multiply, we add the exponents. Remember why that was, so that we can avoid memorization. Remember, this means repeated multiplication 7 times, and then by x 3 more times, giving us 10 times we're multiplying x by itself. Now, the next what I'd like you to do is we are going to take, let's just pick anything, let's just take a base of, say, 3. And we're going to take 3 to the second, and we're going to raise it to the 4th. And our guesses for that, just, actually I'm going to take that and I'm going to change that up a little bit. I'm going to raise it to the 5th and then to the 2nd. If we were to merely guess at what that would be simplified, one guess would be to say, oh, it's 5 to the 2nd, which is 25, or 3 to the 25th, maybe. The other guess would be to say, well, 5 of them and 2 of them I add them, just like I did here, maybe. And the other one would be to say, well, maybe I multiply these 5 times 2 and get 3 to the 10th. And the answer to that is maybe. Let's kind of discover which one it is by understanding what an exponent means. It means how many times you multiply that by itself. So this means I do 3 to the 5th by itself twice. This means I have 5 3s. This means I have 5 more 3s. So if I wrote it all out, which I really don't want to do, that's the whole point of all these properties, I would have 10 3s. Or I could even fall back on this one now because I have the same base. Notice I get 3 to the 10th. Let's try it one more time, maybe with a variable base. And let's do it, say, x to the 4th to the 5th. All right, pain in the butt to write it out. Hence the properties, which allow us to save some time. So this means 5 times I do x to the 4th times itself. What does that mean? It means I'd have 4 x's, 4 more x's, 4 more x's, 4. I'd write x out 4 times. And I'm not going to do it for each one of these, which means I'm going to have 5 groups of 4, giving me x to the 20th. So if I were to ask you right now for $1 million, tell me what the property says I do with these exponents, I'm sure you would guess that I multiply them. So you'll notice, and we'll work with that on the second page, my guess is that I multiply them, and that's actually correct. What that's called is power to a power. And we'll write that out on the next page. One more situation we've got. We've also got something that we call product to a power. What does product mean? It means that we multiply. So I'm going to just take 2 easy little things in here, maybe a 2 and an m, and I'm going to raise it to the 3rd power. Again, I'm going to revert all the way back to the meaning of an exponent. Repeated multiplication. 3 times I'm going to multiply that entire base by itself. And remember Mrs. LaRude said that these are called coefficients, aka outfronters, and multiplication can be done in any order. So I'm going to pull those out front, and I'm going to put my variables at the tail end. Notice what I've got here. I've got 2 written 3 times and m written 3 times. We're going to wait, we're going to do it one more time and see if we can pass the $1 million question. Suppose I were to take x squared, y, and raise it to the 5th. What would I get? Well, first I'm going to write it out. Notice we don't like to write it out, but we're going to do it first just to kind of discover these properties so that we never have to memorize them. Worst case scenario, if I forget what I'm supposed to do with these, do I add them, multiply? Just write it out. So let's go take a look. I've got x squared y once. I've got x squared y twice, and I'm going to do this 5 times. And it makes me a little grouchy, but I'm going to do it. I'm going to take all my like variables and lump them together. I have x squared written. Oh man, this is a pain, LaRude. Yep, that's why we're going to write down the shorter version in just a minute. I've got y written 5 times. Y. Because I said so. Then I'm going to either revert back to my original property that said when you multiply, you add the exponents, or I could even write out 2x's, 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 2x's 5 times. In doing so, either way, I get x to the 10th. I have 1, 2, 3, 4, 5 y's. Now, let's take a look and compare both our answers with our original problem. And if you were in class doing this, I'd have you kind of write down on your paper, what do you think the property says? Take a look. When I raise this product, this chunk of stuff being multiplied to the 3rd power, notice what happened. It came into both parts of the product in the base. Same here. When I took this, and again, look and compare, ignore all this stuff. This is for discovery purposes only. We're never going to do that again. It appears that I simply raised x to the 2nd to the 5th. I multiply those, getting x to the 10th, and this one I raised y to the 5th. It appears that I can just distribute that property in. So let's go to the next page and write that out. What do I do with these exponents when I have a power to another power? When I have a power to another power, I multiply them. What did I do when I had a product to a power, a chunk of stuff being multiplied? Every piece of that product gets raised to the power. So now I'm up to actually 5 properties, I believe. Let's stop for a minute because you're going to be using them all within the problems. They just kind of keep building on each other so that you might have one problem that uses all 5 of them. So let's repeat what they are over off to the side here on your paper. We have said that anything to the 0 power is 1. We have said that when you raise something to the negative power, it means division, and it causes a level change, 1 over a 3 times. We have said that when you multiply and you have a common base, and you might say, oh, I multiplied exponents. No, you don't. Let's remember, again, if you get stuck, you are going to, let's even put numbers in there so you can, what do we do when we have something like this? Don't say a to the 6th. Think it out. You'd write out 3 of these and 2 of these. The property actually says you add those exponents. And now we have 2 new ones today. What if I have a to the 3rd to the 5th? That means I have a to the 3rd twice. I have 3 a's written twice. That gives me 6 a's. I multiply those exponents. These 2 are really easy to confuse and to guess at. Don't do that. And also, what do I do when I have a chunk of stuff to a power? This one's easy to remember. I bring it in. So now we're going to use all, oops, I didn't realize that's off your screen. So now we're going to use all of those powers simultaneously and do a few examples. So what one do I have here? I have x to the 3rd to the 4th. When you say that to the, that's power to a power. It says, remember, don't leave any negative exponents. That's kind of like saying ain't in English. I know what you mean, but it's not proper math grammar. So power to a power. What do? The property says you multiply them, and 3 times 4 is x to the 12th. But let's pretend that you're great at math, but your memory's not so good. How would I get there? I would just list that out 4 times, and the minute I start to do that, I'd say, oh, there's going to be 12 of them. We like to avoid this, but worst case scenario, you've got it in your toolbox to use. Number 2, I'm raising a chunk of stuff to a power. What am I allowed to do? Bring that power in. I've got p squared to the 5th, and I'd have the q to the 5th. And now I've got the other property, power to a power. Don't guess at what that is. Yes, the property says to multiply, but again, if you forget that, think of listing 5 groups of 2 p's. I'd have p to the 10th times q to the 5th. Moving on to the next one, I've got another chunk of stuff to the power, and it's a product. I'd have m to the negative 2 to the 4th and n to the 4th. Power to a power, I multiply. And I don't leave any negative exponents. This means divide by m 8 times. It's going to send it to the denominator of the fraction because it's going to be 1 over m to the 8th power. Notice within one problem, I just used 3 of our 5 laws of exponents. Let's go look at number 4. This y to the third, notice, isn't in the parentheses, so it does not get raised to the -1 power. I'm just going to leave it there for a little bit. Again, it's kind of that old order of operations. I've got to work with this first before I do any multiplying. Well, I've got to bring that in and do y to the -2nd to the -1st. And then I have to do that y to the -1st. What does that give me? The y cubed. Power to a power I multiply. A negative times a negative is a positive. Now I have all the same base. And that means I add up those exponents. And that gives me y to the 4th power. Number 5. Now lots of things going on with number 5. If you can do number 5, you've pretty much got most of these kind of under your belt. I would suggest you to pause the video, kind of test yourself on whether you can do number 5 correctly. So I pause it right now, go do it, then play the video again while I work it out. Alright, so here we go. I've got n to the 5th to the 2nd. Common mistake for that, by the way, is to say it's 5 to the 2nd. It's not. It's 2 groups of 5 n's. That gives me 10 of them. Power to a power, I multiply. What do I do with this chunk of stuff? Well, it's all to the 3rd. So I'm going to bring it in and raise each part of that base to the 3rd power. I'm going to have a 4 to the 3rd. I'm going to have an n to the 3rd. And I'm going to have an n to the -6. This is in no means done. I've got several issues with it. First of all, in math, you do have a recommended, although you can multiply things in any order, we do kind of have a standard procedure for that. We usually put our numbers out front, followed by our variables, and actually, usually those variables go in alphabetical order. Would I mark it wrong if you did not do it like that? Only if I was in a really bad mood. No, just kidding, I wouldn't do it. All right, so first of all, I have 4 to the 3rd, not 12. 4 times 4 times 4. You can either leave it as 4 to the 3rd or replace it with a 64. I don't really care. Then I've got some m's. We have no friends to play with, so I just have 3 of them sitting there. Now I've got this same base. I don't just say, -60. I think about what I'm doing. I'm multiplying. When I multiply, I add those exponents up. So I've actually got 4 cubed, or 64, m to the 3rd, n to the 4th. Now number 6 looks like a mess and it's got all this stuff going on, but keep in mind our first property, anything to the 0 power is just 1. So that's really a 1 there. And I've got 2m in parentheses because it matters. Otherwise this 2 is just to the first power. But when it's in those parentheses like that, I've got to raise it to the -6. So I have 2 to the -6 and I have m to the -6. What does that do? Divide by 2 6 times, divide by m 6 times. Both of them get sent to the basement. And what remains on top? A 1. Now that's not the only way to do that. So I'm going to switch colors here for a second. Some of you might have kind of gone a totally different route. And if you don't abuse the properties and use them incorrectly, it's totally possible that your pathway is a little different than your neighbor's, but your answer turns out the same. As long as you don't break any of the traffic laws here, you will get to the same place. You might just go, let's use a car as an analysis. You might start here and want to go there, and maybe you went this way, and your neighbor went this way and this way. And as long as we're not breaking any math rules, you're both there. And actually, in the same amount of time for that one. This one could be done differently. You might say, well, the root said anything to the negative power means you send it down to be more positive. Make sure, though, that you keep in mind that base, it's all of it. So get it in those parentheses. At this point, this says I've got a chunk of stuff to the 6th. That means the 2 goes to the 6th and the m goes to the 6th. I've got the exact same answer here. Moving on to the next page. A simplified expression for the area of the square. Remember, area of a square is either you can think base times height. Here's method 1. Okay? Then you can say, well, she said to do those out fronters out first. Be careful. Again, when you multiply with the same base, you add exponents, right? I don't add those numbers and make them a 10. 5 times 5 is 25, and it always has been and always will be. x to the third times x to the third, it's 3 x's and 3 more x's, leaving me with 6 x's. Notice I'm not even really saying when you multiply, you add the exponents, because I want to avoid memorizing of rules. Another method, another approach to the exact same problem. You guys might say, I was told that a square is a side squared. Sure is. What's that going to give you? I'm sorry, I wrote it wrong. Let me get that. It's a side squared. Yes, it is. And then if you do it this way, you're going to use your property that says I bring that exponent in, it gives me 5 squared, x to the two groups of 3, 6, which I could clean up for 25x to the 6th. And I'm going to stop this video right here. And I'm not going to do the aircraft one for time purposes. I like to keep these at 15 minutes, so I will probably do that one in class, or you try it on your own. All right.